Tell us your name and tell us about your project. Hello, my name is Edwin Hubble, and my project was centered around what is now known as cosmology. 100 years ago, this field was minute in comparison to today because most people believed the universe consisted of just our galaxy. Because nothing was thought to exist outside the Milky Way, we assumed we were stationary in the universe. I helped to disprove this by showing that a celestial body named Andromeda, previously thought to be a nebula within the Milky Way, was actually a completely different galaxy over 2 million light years away. I began realizing that the galaxies we were observing were all being affected by a redshift. My team and I went on to theorize and prove that the more distant a galaxy was from our own, the quicker it was moving away from us. This was the discovery that rocked the world of science. What were you guys trying to find out? I was studying reflective nebulae within the Milky Way at the time. After finding that one particular nebula wasn't a nebula at all, my objective changed to discovering new galaxies outside our own. I was making observations and notes about each new one we found, such as the light spectrums emitted and their distance from Earth. I measured their distance using the apparent brightness of Cepheids, a class of variable star in each galaxy. I was also beginning to classify different types of galaxies based on their shapes. While recording this data, we realized the further a galaxy was from our own, the greater the redshift, which meant we were living in an expanding universe. Where did the project or event take place? At the time of my most famous discovery, I was studying galaxies from the Mount Wilson Observatory in California. I'd been working there for 10 years when I finally published my work. What other significant events were happening around the world at this time? I published my paper on May 15th of 1929. Other major events that were happening that year were the stock market crash that led to the Great Depression, and the Vatican gained independence from Italy. Over the next few years, Franklin Roosevelt was elected president. Amelia Earhart flew solo across the Atlantic, first woman to ever do that. And Hitler became Chancellor of Germany. Who else was involved in the project? For the first several years, most of my work was done on my own due to its nature as an astronomy graduate student. But after graduating and beginning my work there as a member of the staff, and my discovery of the first few galaxies at Mount Wilson, Milton Humason began aiding me in my efforts. He was the astrologer who was able to convince much of the math world of the linear dependence between distance and speed of a galaxy. By the mid-1930s, I was also working with renowned mathematician and physicist Richard Tolman to delve deeper into the question of whether we were truly in a static or expanding universe. What was your role in the project? As a graduate student, my dissertation was over photographic investigations of faint nebulae. After graduating and getting back from the war, I was brought into the staff and I studied the slight reflective nebulae. It was while doing this that I noticed the Andromeda Nebula had a variable star within it. After measuring the light waves from the star, I estimated it was 900,000 light years away, which was later estimated to be over 2.2 million light years. This would make it far beyond the outer edges of our galaxy. I concluded it, in fact, was another galaxy of itself. This led to me spearheading studies on more distant galaxies, and by 1929, we had found 46 galaxies outside our own. What impact did your project have on the physics community? My project affected the physics community drastically. Not only did we learn that there existed millions of other galaxies in the universe, it also confirmed the Big Bang theory we now hold today. This meant the universe has an age we can measure as well as predictions for its future. These predictions boil down to 3 types of universe we might be living in: open and ever expanding, flat and only going to expand to a certain point before slowing to a halt, enclosed, where we will eventually collapse back in on ourselves. My project also solidified Einstein's theory of relativity, which had previously been flawed because it required either an expanding or contracting universe in order to be consistent. How do you feel about the Hubble law being renamed the Hubble-Lamissiere law? I don't necessarily care one way or the other. It is true that nearly 2 years before my published work, Georges Lamissiere theorized that the expanding universe could be the cause for the Doppler effects we were observing in distant galaxies. But I feel that people focus on many of the wrong motives these days, and the main goal of science is to progress our understandings. I believe the International Astronomical Union meant no offense, and my work is still useful regardless of the name it is given. Thank you for your time.